5. Two spherical conductors having capacitance 2 microfarad and 40 microfarad and potential 30 volt and 50 volt connected by a wire, then what will be the common potential charge on each conductor and energy loss after sharing? Solution: C1 equals to Q1 by V1, Q1 equals to C1 V1 equal to 600 microcoulomb. Similarly, Q2 equals to C2 V2 equals to 2000 microcoulomb. Common potential V equals to C1 V1 plus C2 V2 by C1 plus C2, Q1 plus Q2 by C1 plus C2 equals to 600 microcoulomb plus 2000 microcoulomb divided by 2 microfarad plus 40 microfarad. After solving, we get 43.34 volt. Charge after sharing is given by formula Q1 dash equals to C1 by C1 plus C2 into Q. Putting the respective value, we get Q1 dash equals to 866.6 microcoulomb. Similarly, Q2 dash C2 by C1 plus C2 into Q equals to 1733.2 microcoulomb. Now, loss of energy delta U is given by delta U equals to C1 into C2 by 2 into C1 plus C2 into V1 minus V2 का whole square. Using all given value, we get delta U equals to 8 by 3 into 10 to the power minus 3 joule equals to 2.66 into 10 to the power minus 3 joule answer. Question: two charged metal sphere of radii r and 2r are temporarily placed in contact and then separated. At the surface of each, which sphere has greater value for the following? A में charge, B में charge density, C में potential and D में electric field. A में which have greater energy stored. Solution: as in sharing, charge divided is proportional to the capacity. Hence, Q1 by Q2 equals to C1 by C2 equals to 4 pi epsilon naught R1 by 4 pi epsilon naught R2 equals to R1 by R2 equals to R by 2R equals to 1 by 2. This implies 2 Q1 equals to Q2. So, the bigger sphere has greater charge. B. Charge density sigma equals to Q by 4 pi R square. Hence, sigma 1 by sigma 2 equals to Q1 by 4 pi R1 square by Q2 by 4 pi R2 square equals to Q1 by Q2 into R2 by R1 का whole square equals to 1 by 2 into 2R by R का whole square equals to 1 by 2 into 4 2. Hence, sigma 1 equals to 2 sigma 2. So, the smaller sphere has greater charge density. C में potential of a spherical conductor Q by 4 pi epsilon naught R. Hence, V1 by V2 equals to Q1 by 4 pi epsilon naught R1 by Q2 by 4 pi epsilon naught R2 equals to Q1 by Q2 into R2 by R1 equals to 1 by 2 into 2R by R equals to 1. Hence, V1 equals to V2. So, the both conductor acquires same potential.